Alright, so we have the diagram for the question as replicated here on the board. You have a circle with certain triangles and stuff inside there. So the question reads as follows. The diagram above shows a circle with center O. A line ON is drawn perpendicular to AB. OA is equal to 10 centimeters and AB is equal to 16 centimeters. The length in centimeters of ON is. Alright, so again, we're going to approach this as if it were laid out in a paper 2 context, right? Which means that we're going to work it from scratch and arrive at one of the answers that they have there. Excuse. Alright, so you have a circle, you have the center O, and you have a triangle. Now, if there's a straight line from the center O to a point on the circumference, that line is a radius. So in other words, what we have here now, we can say with confidence that OB is the same as OA, because if OB is a radius, then OA would be a radius too. So OB would also be 10 centimeters. And if OA is 10 and OB is 10, both of them being radii, that means that triangle OAB is an isosceles triangle, right? So that this line here, AB, which is a chord, because we drop a perpendicular from O to here, because this is a perpendicular height, it means that this point here is the midpoint of AB, right? That is you could deduce that based on the properties of a circle, right? If you have two radii here, that's an isosceles triangle, which means that this point, the apex, will be directly above the midpoint of AB. That is the only way that this could be an isosceles triangle. And if we drop a perpendicular from O, we will land on the midpoint here. That will be the point N, right? Which means therefore that we have two right angle triangles. We have 10 here, and if AB is 16, it means that AN is 8 centimeters here, and AN is 8 centimeters here as well. Right? So it means then that we basically looking at a right angle triangle. You have 10 here and you have 8 here. Now, in a situation like this, you could do a couple of things. You could use Pythagoras theorem and find the length ON, which is what we're trying to find. So let me just do it the long way. You'll see why it's the long way just now. By Pythagoras theorem, we know that the square of the hypotenuse, right, the OA of course would be hypotenuse, is equal to the sum of the squares of the other two sides. So 10 squared will be 8 squared plus ON squared. So we're trying to find ON. So 10 squared minus 8 squared will be ON squared. So 100 minus 64 is equal to ON squared. So 36 is equal to ON squared. And if 36 is ON squared, then the square root of 36, which is equal to 6. Well, let me continue. Let me finish it up. The square root of 36 is equal to ON. So 6 is equal to ON. So ON is equal to 6. Alright? We do that using Pythagoras theorem. Now that's the long way. And the reason why I say that is the long way is because in the multiple choice, a lot of the questions are such that there are certain little things that if you know them, it will make your life a lot easier in terms of being able to finish the question a lot faster. So instead of having to take all the time to go through this, if we are aware of what we refer to as Pythagorean triplets, right? Pythagorean triplets, or some people say Pythagorean triples. It makes no difference, it's the same thing. Right? And if you're aware of that, it makes your life easier, because if it's something you know, then from the time you see 10 here and you see 8 here, you know immediately that that is 6. And I'll explain that just now. So I want to invite you to go on Google and search for Pythagorean triplets. Alright? Pythagorean P-Y Pythagorean of or pertaining to Pythagoras triplets. Right? Search for that in Google, boom, and you'll find a lot of things. Now the main thing is to just be aware of what it is. A Pythagorean triplet is simply a trio of numbers where a trio of integers, most important, a trio of integers that conform to Pythagoras theorem, right? And what you'll find is that there is an infinite number of Pythagorean triplets, right? But there are some simple ones. The simplest one being, of course, 3, 4, and 5. So if you look at it, Pythagoras theorem, 5 is the largest number, of course, so 5 will be the hypotenuse. So by Pythagoras theorem, the square of 5 is supposed to be the square of 3 plus the square of 4. Let me check it out. 3 squared is 9, 4 squared is 16, 9 and 16 is 25. 25 is the same as 5 squared. Right? And that's a basic example. So you have 4 examples that you need to know for CXC purposes, for CSEC purposes. Knowing these 4 triplets will save you a lot of time in a multiple choice. Remember, in your regular multiple choice, you have 90 seconds to answer a question. Alright? And if you could save time doing all of this by knowing this, then you could use the time that you would gain there on another question where you might need a little more time to do it. Well, that's part of your preparation, or that's part of your strategy. So by preparing adequately, it puts you in a position now to use some extra strategy in the exam itself. So you have Pythagorean triplets. 3, 4, 5 is one, 5, 12, 13 is another one, 8, 15, 17 is another one, and 7, 24, 25 is another one. Let me call them out again, and you could write them down as the 4 that you need to know. That's 4 basic ones, right? There are whole set after that you don't really need to know. These 4 you must know. 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Right? Just, you can memorize that if you want. You go into a multiple choice exam with that, and boom, cut your time by 2/3 in a lot of questions. Right? So the next thing you need to know is that multiples of these would also be triplets. So if you have 3, 4, 5, if you multiply each of those numbers by 2, you get 6, 8, and 10. And that is what I was able to use here. Right? 5 by 2 is 10, 4 by 2 is 8, and 3 by 2 is 6. So once you have the basic ones down, you can multiply by any number, and those would also be Pythagorean triplets. Multiply by any integer. So if you have 5, 12, 13, then you can say 10, 24, 26 as a Pythagorean triplet too. So in other words, if you have a right angle triangle, if you have a right angle triangle, let us say where the hypotenuse is 26 and one side is 10, then by simply applying a knowledge of this, of course, if you observe that 26 is 2 times 13 and 10 is 2 times 5, then you know that the other one is 24, which is 2 times 12, etc., etc., etc. Right? That's basically it. 8, 5, 17, same thing. 16, 30, 34, 7, 24, 25. Let me say multiply by 3. 21, 72, 75. Alright? So that's basically it there. You could solve this question either using Pythagorean triplets, which is very fast, or you could do the long method and use Pythagoras theorem. Either method you use, the answer is that ON is equal to 6, which is to say then that the answer for this question is answer B, 6 centimeters.